right, thanks everyone. Mitsuhiro and myself, I'm Erin Boyd. I've been working on the raw block device enablement for Kubernetes for a while now. Yep. But like all things, and everyone complains, it's slow to move it through the process, but appropriate to get it right. So just a quick overview of the goals. We wanted to enable raw block storage within Kubernetes. Today, it defaults to always put a file system, even if you start off with a raw block device. So if you put something on GCE or AWS, it will start as a block device, but it always defaults to putting a file system on things. And we wanted to provide flexibility for users and vendors to actually use raw block devices. So if they're using Cassandra or a high performance database, they can actually leverage using the device is what it was made for. So the first thing we wanted to do within that was to agree on API changes for block, and those have been agreed upon. I don't think there's any contention right now on those, and I'll quickly go through those in the next slides. And provide a consistent security model for block devices. In doing all these and implementing, we also have to implement a new interface and plugin interface, which is what Mitsuhiro is looking at, and that's been a challenge, and those are really what we want to discuss today. So quickly going over the API changes. The first one is in the persistent volume. You'll notice under the access modes in red, we have what's called a volume mode, which is block today. So it will support either file system or block as appropriate values for that. Same with the persistent volume claim. And we kind of went round and round. Well, why do we need it here if it's going to be there? And we wanted to make sure that we were very consistent and specific about how we were going to use things, because of course we can have file on top of block. And so therefore putting it in both the PV and the PVC made our intent of how we were going to use the volume very intentional. And then the last place that we need to update the API was in the pod definition. So we added a new section called volume devices, and then a device path. Since we're no longer pointing to an actual mount path, we want to be very specific and actually put in the device path. This is consistent with the way that the container runtime also defines device paths. And just all of them, it's pretty much the same. So the challenges, of course, are getting the API changes merged. Anytime you make an API change, Steve.
Just real quick. So basically,
if you're using a file system PV, then you use the volume subsection. If you're using a raw block, then you use volume devices in the pod spec. If you go back one slide.
Yeah, we haven't quite finished that in how we're going to do file on block. File on block will work like it already does today.
Right.
Right. So you would just use this typical plugin that you're going to use, because that's how it works today.
You just specify the claim. Or I'm just trying to understand, like in the pod spec.
Volume.
Is someone talking into the meeting?
Scott drew
Ice and mouse.
Scott, we can hear you.
Yeah, I was just saying that the volume devices just kind of mirrors volume mounts. So
okay.
That's all.
Yeah, today it says mount path instead of device path, because you're actually mounting to a path, right? It already has a file system on top of it. This is actually mounting to the physical device without, the directory that a file system would provide. Does that make sense? Okay.
Yeah, and this is in the container, right? That's in the pod.
Correct.
Right.
Yep.
Just a very quick question. You have in this example, you have a specific name. Is that the system going to name it that for you?
Now we just put it in there as an
example. How is that naming gonna happen? So that it can be consumed inside the pod? I'm sorry, maybe in the persistent volume claim. I'm sorry. This is the
go back up. Here? One more.
Okay, so go back to the pod again. Just one question. I'm sorry to take time from this, but I'm just trying to make sure, how is it going to be consumed by the pod? Where is going to find the block device?
Is at the device path.
Okay, that device path assumes in this one is a Zen hypervisor. What I'm trying to say is, like, how is the container going to know that that is the name of the device?
how is the container going to know?
It doesn't matter. It doesn't matter. It's just a device path, right? It's just a raw device.
So when I'm deploying this pod,
Yes.
I don't know what node it will run on,
That's right.
and I don't know what that device is. So how do I know what path that thing will show up as?
So you have to pre-create the devices today. This is all static provisioning.
Okay.
So you will have the device path.
Well, the path here in the pod specification, this is just the name of the device inside the container.
Correct.
And whatever you put there, it will be there. You can use SDA, XVDB, whatever you want, we will put it there.
How is the storage device in the host going to be mapped to that location inside the container?
Docker does that.
Yes.
Docker does that.
We'll talk about that. Yeah. Yep. That's coming up.
Okay.
We're trying to figure that out.
Thank you.
Actually, that's one of the challenges. Nope. Please questions. That's why we're here.
Is the scheduler gonna know if a pod has storage or not?
Yes, eventually. There will be changes in the scheduler. Michelle is certainly working on that.
So I
for
think
local
we're
storage.
confusing a lot of things here.
Yeah.
This is gonna work with remote storage, just like volumes work today, where you attach a remote storage to a node and you go through attach, detach, but instead of doing mount, unmount, now you just link this that got attached into the container.
Are we good then? Okay. All right. No, I want people to ask questions because how do I get rid of that? Oh. See? Okay. So challenges, like everything else, getting something merged, working with FeatureGate. We've never done that personally, so we've had to kind of figure out the tricks of the trade for that. Plugin changes, of course, adding this is very disruptive to the environment, whether or not a plugin is going to support it. That's why we've just started with a couple, and we've also started with just static provisioning so we can slowly integrate this into the environment. And then Mitsuhiro wrote a new interface for the plugin, a block volume mapper, and this is where we really get into the nitty-gritty. AWS, GCE, and Gluster are our three.
EBS, GC,
Yep.
EDS,
Yep.
cluster block.
Yes. iSCSI, essentially. Yep.
Okay.
Yep. Okay. So
Okay, so this is a new interface for the plugin. So currently we have a mountain interface for each plugin, but the mountain interface is not doesn't fit to support the block volume. So we will introduce a new interface called the block volume mapper and block volume unmapper. So each plugin have to implement this block volume mapper and the block volume unmapper. So there are mainly three methods, and the first one is the setup device. This is the same. If the volume plugin doesn't have an attached interface, so each plugin have to implement setup device, and inside this method, plugin have to attach a device to the Kubernetes node. Also, plugin have to implement the get global map path. This method have to return the global map path, like I showed this one. So in this example, so the path is the variable Kubernetes plugins, Kubernetes IO, FC, volume devices, blah blah blah. So we create a symbolic link under this directory. Also, the plugin have to implement one more method, the get pod device map path. This is the path for the under pod directory. So the path is variable Kubernetes pod and pod UUID and volume devices, Kubernetes IO, blah blah blah. So these two methods need to be implemented to the new plugins if the plugin will support the block volume.
and you'll notice that we have the new directory volume devices to differentiate between the two, as you would see the path today in Kubernetes when you're looking at your volumes.
You can show the example.
Should we go back? These,
Yes, this one.
which one?
Next one.
That one.
So as experience was, we will introduce the new directory for block volume. So the name of the volume devices. This is this slide shows the volume devices plugin directory. So we will store the symbolic link to the physical device. In this case, the physical device is SLADEV loop 2. So we will create a symbolic link to the device, and the symbolic link name is photos UUID.
On the previous, I'm only bringing this up because you're talking about the paths now. One of the questions that I have, that we have actually at Portworx is how do you go from a node on just a path to a disk on a storage system? So how can you track? You just know the path on a node. How can you go backwards and say this path is on this PV and belongs to this PV and this PV belongs to this storage system? And how do you connect back? I'm only bringing that up because you're already designing how is that path going to be created. So as you do that, just keep that in mind, how you go backwards to service that node as a, debug it and things like that.
How? Okay, so let me just repeat that to make sure I understand what you're
You
asking.
see that path right there with the massive UUID
The
on
very
it?
bottom one? In
Yeah.
red? Yes.
How do I go from that to the actual storage volume on a storage device as a storage vendor so I can service it? So let's say I found an IO error on that path, how do I go then to that device and to check out what happened to it?
Oh, so in this in the past,
We don't have to solve it now. Just keep that in mind. If you want to take that offline, that's fine.
It's possible.
It's possible.
Yeah. So in this past, so
Pieces of that path and run other commands to say this is X volume.
Okay, so this takes me to the next part, which is CSI will have a volume hash ID on that thing. Okay, and so what we can talk about is then how is the CSI path going to go back to a storage volume? I don't want to solve it right now, but I just want to keep that in mind that we need a method to go from debugging a path to a storage system.
Correct.
So today, when you implement volume plugins, you need to implement a function called construct volume spec, and you'll be given the path of. Today, for file systems, you're given the file system mount path, and from that, you have to be able to reconstruct your volume information you need in the provider. That's currently how it works today for file system volumes.
Is that I'm sorry, I'm new to that. Is that a command line program or something?
No. It's part of the volume plugin API. So even today, there is a requirement that volume plugins have to be able to, get their information from the mount path.
Yes. Okay.
So we're following the consistency of what's already been set forward with the volume plugins in a file system to do the same for block. And instead of pointing to a mount path, we're actually pointing to a device path. Does that make sense?
As long as we can reconstruct.
Yep. Yeah, absolutely.
This device. Fine. Just as long as the documents are figured out.
yeah.
Okay.
Yes.
Yep. Do we want to talk about the silent replace? Okay, so Michelle and Saad, we were trying to get some of the stickiness of our PR worked out, and in that conversation, we surfaced probably a pretty bad bug in Docker and many of the other container runtimes. I can't remember who brought up the question, but what would happen if we removed that device and added another device with the same name, and we're using that symbolic link, would we actually be able to read the data underneath there, which is a pretty bad thing to do. And yeah, you can, and it doesn't even blink an eye. So yeah, we're trying to figure out a way around that.
Explain that one more time if you do it.
So if you're pointing to a raw block device on disk /dev/ SDB. And I have a symbolic link that I've created and I'm pointing to that device.
On the host or in the container?
On the host.
On the host. And then I go remove that. And let's say I add in Saad. He in the meantime has created /dev/ SDB. Somehow the timing works out. Can I attach to his
So he's added another.
lock device? I delete mine and he adds another one. But before it's attached to
The
anything.
symbolic link remains. Right?
Yeah,
It's a
yeah,
symbolic link. It'd
yeah.
have to be a hard link.
Well,
So
that's the problem.
So this is like a 30-year-old problem, and what
And
what
I'm glad you said
and
that
what-
because
and
I
what-
said we can't be the only
yeah,
people
and
that have
and
just realized.
and when the first spinning disk came out, the simple fix is to, when you symlink, you open a file descriptor to that thing, and the kernel promises that it won't reuse device names for things that come in as long as file descriptors are open. So if you have SDA, for example, and if you keep a file descriptor open via some process,
Yeah.
the kernel will lose the drive. And when Saad adds his new thing, that name won't be reused until you do close your file descriptor.
Do you mean additional?
Yeah, that open file descriptor tells the kernel that I'm using it, and so the kernel can't just free the name and use it for something
So
else.
you couldn't create one of those
Yeah.
volumes at the same time.
Just a
It's
simple
already been
open
taken.
system call, and you need to have some background process or something that is around to hold on to that file descriptor.
Okay.
That's assuming even if the disk disappears.
Yeah, the name won't be reused.
So wait, if it's a process that has to keep the file descriptor open, what happens if the process dies?
Then you're, it closes the process.
So eliminate it.
Unless.
Can we get around this one by UUID? Unless you start passing file descriptors through sockets, and that's evil. Yeah.
We'll be sure to do that then, Michael.
So can't you just refer to the device by UUID?
Yeah, and that's what we were talking about.
I think the UUID also is a symlink to the actual device under /dev. So there's always going to be some device directly under the root /dev.
Right.
And then you might have some UDEV rules that will create symlinks to it with UUID and ID and path and that kind of thing. But it's still a symlink. Yes, but the problem is when we pass, even if we pass the UUID symlink to the container will dereference the symlink directly down to /dev.
Yep.
Yes.
So why is this a problem? Is it just the order in which you delete the stuff?
I don't think it's the order in which you delete it. I think it's just the possibility of reusing that device name and
Yes.
having a symlink available to now when that new device has been created, that you can automatically then access the data that's on that device.
Kubernetes is orchestrating the volume mounts and directory linking, right? It's not anybody on the host that's linking. I don't see where the issue is.
I mean, someone can log into the host.
Yeah, but that's out of our control at that point, right? So lots of log device.
There that we expect. That's common in dealing with a lot of device files. If you're going to open one and use it, you better make sure the data is there that you want to format, particular label on your disk, or whatever you want to do. So it's there.
Yeah, but we can't control the way the application is going to use the raw block device. So we have to put.
Oh, it shouldn't use the wrong one.
Well, and no, I'm glad you're bringing this up because this came up in early conversation. Like we had entertained the possibility of whether or not we were going to allow people to use raw block devices and have that be an administrative function within Kubernetes to completely disable that because it is a different animal.
I don't know if one of the things about is that you could do a bind mount of the device as a.
Please.
Thank you. One other idea is you could actually do a bind mount of the device to a device. So I don't know how different that is from a symlink, but that might it might actually do those locks you guys were referring to.
There's actually 6 different ways to do it.
Yeah.
it's like 6 different ways to do it. We can just go back to literature and choose the trade-off that we like. There are ways to configure the Linux kernel to say, once you've used SDA, go to SDZ until you decide to reuse it again. There are some kernels that allow you to do that. So,
well, that's why we're here. I mean, we need the insight of the actual storage vendors.
That's where I'm at clear. It's like, where is the Kubernetes workflow? It's actually.
So there isn't a Kubernetes workflow. Let's say you set everything up,
right,
and then I go and pull the cable.
Right.
So the node has lost all its block devices.
Right.
Containers might be in trouble, whatever. And then I connect a different cable, and 10 new drives show up, and these containers will go and scribble on those new devices, thinking they are the old ones.
And
Yeah, but
that's
that's
sensitive data that container
Right, but
shouldn't have
that's,
access to.
I mean, if you're going to use raw block devices, you have, as an application, you have to know that that can happen. And you got to make sure that data is consistent from, program instance to program instance.
So in this case, the application won't even know it's an ABA problem.
Are there going to be some situations where the right answer may be not to complicate the API at this level, but instead to employ some of the tendency tools like namespaces and permissions and at that level of abstraction instead to offer the security features you want? So you would tell a cluster administrator, these nodes have some label on them that can only get scheduled by these jobs, and that, you restrict the workloads that way. At the node level as opposed to at the device level? Is that something that can even be considered, or is that?
I think it's, even below that. So
the concern here is that when you have a workload, everything can be working. Okay.
Record, I hate my name, which is Mike, every time this happens.
So the concern here is that once a workload is scheduled, pod is scheduled, it's working, everything is working okay, and it's using a block device. That block device could disappear, and another block device could come in and take its place. And as far as the application is concerned, nothing happened. And so you could have one user's data end up in some other user's pod, which is very, very, very bad, and we want to prevent that from happening.
And is this a Docker-specific problem? Essentially, that example that you showed?
No, this is just a container runtime problem where we were talking about, does this already exist? Can we do this today? And played with Docker, and we definitely can. So this is not specific.
This is a Linux problem.
Yeah, it's a Linux problem.
Yeah, I think that's my question too. I'm wondering if, when you have these situations, if you want to employ things at that point, like encryption and keys and things that live in the pod. So I'm not sure. I'm trying to figure out exactly what the specific use case is, because as I'm realizing, as I'm listening in the room, it does seem like we don't want to solve, Linux issues at the same time. It sounds like you have a good handle on it, but I don't understand exactly what it is.
We don't want to expose another user's data inside a pod that they shouldn't have access to. That's
a quick question.
Then it won't happen. Okay. Oh, hold on.
Just, sorry. Don't we have the same problem today?
Yes.
I mean forgetting block storage completely in our normal containerization of, using file systems. Don't we have the same problem?
Well, it depends on the storage drivers. If they do the hard work of maintaining the descriptor and everything, you don't have the problem.
Nobody's going to do it. I don't think they do that. They just plug into SD and then just format it and consume it. I think the same problem is available today. I mean, right? It's all we do.
No, the same problem's not available today. So if say you had a disk that had a file system on it and it got mounted into the container, if you pull that disk out and replace it with a different disk, it is not going to get mounted at the same place, even if there was a file system on it. So with file systems, you're protected because of the mount.
No, but the disk, the file system is on, is still a block device. And that is still SDXDA.
Yes, but when we pass the mount to the container, we give it the mount, not the device.
Right.
But that mount point could still come from another disk with another file system.
So the file system holds that descriptor open. The mount is your guy who holds that descriptor open. And you have to tear down a file system. You just can't replace.
So as long as the application is still running.
No, as long as the file system is mounted.
Okay.
Yeah.
So let's say the application goes down, the mount goes down.
No. No.
Well, I'm just saying the node goes down.
The
node
application
comes back up completely. Right? Node goes down completely. Node goes up completely.
That's a different mount. I'm
just saying that isn't that the same problem?
No, but then the container will restart, and then that other comments come into picture where
then the container will have somebody else's data.
Okay.
Right?
We only have 13 minutes left, so.
I'll take it offline. Just wanted to see if it was the same.
Yeah,
amount.
no, we don't have the same problem with file system. This is unique to block in so much as we know. I mean, so.
And then I'll let it go. But I'm just curious. Did you look at just using disk by ID instead? That actually is the identifier of the disk. So don't allow mounting by dev SDX, for example.
Yeah, so the problem is that even dev disk by ID is a symlink to /dev SDB or something.
Oh, I see.
It still resolves back. Yep. So that's the problem is the symlink where it actually ultimately resolves to is going to be that physical block device, which could be recreated underneath it.
So unless there's a rules entry that you can do or a file descriptor.
Exactly. So we hadn't thought about the file descriptor. We could definitely do that. We'll put this in the prop and invite you all to comment on how we should proceed forward. But sure, no.
So maybe using the rules and the reference for the block device and the naming, that's all. My other concern is, let's say you ended up doing a symlink, right?
Mm-hmm.
And it'll go to the root file system, dev, whatever. Let's say that device actually doesn't exist. You would end up writing to the root file system. To me, how do you prevent that? That's a bigger problem. You see what I'm trying to say?
Yeah.
Because now you have actually gone to the Linux root file system and you have actually corrupted it.
Yeah, I think
so that one to me is a bigger problem than we may be able to solve that. So that one I'm more fearful of.
Yeah,
I feel like when you actually connect the device to the container, the device has to exist.
You check that only during the time when you're creating basically sync. See, there is no C groups for block devices, right? So all you have done is you have taken basically that root file system namespace and mounted it onto that container's symlink, right? And you run FIO there. Device comes or is not there. It doesn't check. It is going to do a write.
I think Mitsuhiro did some experiments, right?
Yeah.
When you actually pull the device, the container failed to write to it.
a side effect is that the container has an open reference, so the path doesn't go away. So Gopal and I have worked in a previous life on these same problems, and
I just wanted to point out.
No,
you pointed out one problem that this could be secondary, and if it's solved, then that's fine. I just wanted to.
And we had that in the original proposal. I think Tim Hawken brought that up. You know, what if we went to the root file and started writing backwards and overwrote the kernel? I mean, you know, we definitely did consider that and have experimented with that. But I'm glad you brought it up. So. It's 8:05 is the prop, and people can go in there and comment or add in what they think. That PR is constantly locked, so good luck if you can get in there without a pink unicorn. More power to you. Did you want to go over? Should we show these or not? We have some screenshots of this working, but we don't have an actual demo to show right now. How useful that is. Do you guys have any other questions or concerns? Or I know I have gotten a lot of feedback from the community. The need for this is great, but I think Saad and I have both been conservative in that, given, the potential of this, that it should be something that we're slow to adopt and make sure it's solid before we put it out there in the community. So the more people who want to have their expertise of their previous life and comment in there so we can have it be in the right direction, that's much appreciated.
Yeah, hey, Erin.
Hi.
So what else is there left, or is it already possible for an arbitrary third-party flex volume to take advantage of this? And, if they're for mounting a device to be able to surface it to a pod as a raw device instead of a file system.
So none of this has been merged. You have to kind of piecemeal a bunch of different PRs we have open and attempt to get that to build correctly. So we're still really working out this interface design to see if that's the right way to go, as we ran into this problem late last week, to make sure we aren't able to silently replace the disk. That's kind of the last point. Then we have some actual plugin changes we still have to make and some testing. So that's what's left in the PR.
So, but it's not something that's just.
So it's not something that's just going to be available to in-tree plugins, that'll also be available to, out-of-tree flex volume plugins and such?
Yeah, I mean, the API can be adopted to understand whether or not you support the block volume. The plugins will have to be changed in order to provide this support explicitly. The default is, not. You'll add the volume mode in and say block in order to indicate that I want to use block and therefore follow this alternate path. Does that make sense? Okay.
So,
Shopkery.
Understand says we are not going to extend flex volume, but most people come to CSI.
Right, so in the CSI spec, there is a spot for block volumes. Right now, it's intentionally left blank until that implementation is agreed upon. This is kind of the first step, as all things into CSI will be. How do we get the best implementation fleshed out, and then we'll decide what we're going to adopt. This is, pre-alpha right now, to move to alpha 1.9 hopefully, and then eventually that will be the CSI.
As far as CSI is concerned, for alpha, Mike.
As far as CSI is concerned, for alpha, we're going to ignore local storage because we're developing in parallel. And then for beta, we can look at convergence of local storage and CSI.
It's not just local storage.
Sorry, block, yes.
And that's
Misspoke.
an important distinction, that the two are commonly equated, and obviously have similarities, but we're just looking at the raw block devices.
So targeting a drop of Kubernetes 1.9 alpha release
Correct.
for block storage.
For
So
block.
for folks that want to experiment this, 1.9 will be what you should target.
It won't be file. 1.9 will not support file system on block, correct?
Well,
We should point that out. We can't
hold
put a
on.
file system.
We already do file system on block. That's
But it's a different thing. But you can't have a raw block device, or you can have a raw block PV and in the container put a file system on it and have put files, because you can't mount. How can you mount inside the container?
So isn't it a problem of just privileges?
It is a problem, but that's what I'm saying. You'd have to run a privilege pod to get file systems created from within the container
Yes,
to work.
yes. So that is a privilege problem.
But that should be called out too, right? Like we don't.
Yes, I mean, we have been pretty clear in our proposal in the milestones that we've put in what we are doing in each one of the releases. And if that's not, please comment in the PR.
So
it won't automatically create the file system. So
Not an
let's say I do
automatic thing
block, PV, PVC, and in the pod, how does the file system get installed then?
So if I have a block device connected to my pod and I want to put a partition and a file system on it from within the container, it's not going to work unless the container is privileged. You can put it on there, but you couldn't mount it.
it's the same rules as today.
Yeah, right. And what she's saying, the workaround is you would, instead of doing that, you would just use a file PV, like one of the standard PVs that we have today, but you couldn't create your own custom file system on it. There's a little bit of a nuance there that's weird.
So can you clarify your CSI comment a minute ago? So you said that the block device support isn't going to be in CSI, and but clarify. So it's not going to be in the Kubernetes CSI implementation, but block devices are still in the specification for CSI.
Correct. So the CSI spec left room for block devices, Kubernetes doesn't handle block devices at the moment. It's being worked on in 1.9 in parallel with the CSI work. So instead of trying to make them both work together while they're both getting implemented, we'll just have the CSI implementation of Kubernetes for alpha not support block. And then in a subsequent implementation, when it goes to beta, we'll add support for block.
Just Brad, if we can't run a privileged container with, or if our recommendation is that non-privileged containers using block storage, I don't see how we can ever use it, because apart from mounting, most people will try to query the device, block size and capacity and whatnot. And those are ioctls which need capabilities and privileges. So if we say that we want to support block storage with non-privileged containers, then the amount of the use cases get like crippled to like a very small fraction.
Yeah, that's my point. It's like these are going to be mostly privileged containers that this will be useful for.
But then once we say these can be privileged containers or could be, then we can do mount. Then we can do mount.
Yep. Just like it works today. Yep. Great. I think, did you have anything else? Yeah. Okay. Yep. Is that good? 2 minutes to spare. All right. Thanks, everyone. I'm going to stop the recording.
Oh, yes.